about the first half, we're just going to talk about basic things. Basic things that we need to know about triangles. That we're going to use throughout geometry. Okay? So we're just going to talk about how to name a triangle and different parts of a triangle here in this first section. How you name a triangle. Okay? Similar to how you name a line. Similar to how you name an angle or a segment. You draw a mini triangle. Just like when you name a line, you draw a mini line symbol. When you name a triangle, you draw a mini triangle symbol. A mini triangle. And then you use the corners of that triangle. 20 parts, the corners, we're going to call those vertices of the triangle. And it doesn't matter when you're naming just one triangle, the order. Okay, so to name this triangle, use those corner points. How do you want to name it? Order doesn't matter. ABC. A, B, C. You could have named it CAB, BCA, ACB. Doesn't matter. Just use those corner points. The sides of the triangle are just the segments that make up that triangle. So give me one side or one segment that makes up that triangle. What's one of them? Huh? A to what? So segment.
B.
AB. That's one side. A to B. Right there. What's another segment that makes up that triangle? Okay. B to C. Again, we start at point B, we go to point C, there's that segment, and what's that final segment? Parker. C. And segment, C to A. And C. Okay. The vertices, those are just what we call kind of the points or the corners of the shape. So the vertices of the triangle are just those points on the corners. So A is a vertice, B is a vertice, and C is a vertice. That's kind of a fancy word for those. A, B, and C, those points are the vertices. The corners of your triangle. And the angles are the same as the vertices. Okay? No other angle is sharing this vertex right here of A, so we can use that method. We can say angle A is an angle of the triangle. We could also say angle B is an angle in the triangle, and we can say angle C is the angle in the triangle. You could use the 3 points method as well. You could have said like BAC or BCA, BA. Or just, when it's just a solo triangle, I like to use the vertex method. Just use the vertices and put an angle to one side. Questions over that? So we take a look. We're going to classify triangles. We're going to see different types of triangles all throughout geometry, so we're going to work on classifying them. In order to classify a triangle, okay, there's two ways. One way is by their angles, and the other way is by its sides. Okay. And all triangles have at least two acute angles, but we use that third angle to help classify it. So we take a look here. Some of these are kind of like based off the definition. Very easy to tell. So the triangle where all three angles are acute, meaning all three angles are less than 90. What do we call that? You're close. Big angle. All three angles are acute. You would call it a. If all three angles are acute, it would be an acute triangle based off the angles. If all three angles are acute, it's an acute triangle. Okay? Well, what about the second one? A triangle with one obtuse angle, we would call that an obtuse triangle. Okay? So two of the angles are going to be acute, but you're going to have one obtuse angle. So there's one obtuse angle that makes it an obtuse triangle. Okay? What about a triangle with one right angle? See a right triangle. And all the other two angles are going to be acute, so you're going to have one of those angles being a right angle. Okay? An acute triangle with all angles congruent. This might be a little different of a word than you've heard before. An acute triangle with all angles that are congruent is called equiangular. All one long word, equiangular. A lot of times what happens is we get acute and equiangular mixed up because all three angles are acute, but what sets them apart? If all three angles are the same, it makes it equiangular. These first four deal with how to classify by angles. So you use these to classify a triangle by the angles. And you only use one of them. So you will never have a right obtuse triangle. So you'll never have an acute right triangle. Okay? Or an acute obtuse triangle. You only pick one from that section based off that one different angle. Okay? So these next three are dealing with the sides. So Celeste, what do you call an acute triangle with all the sides that are congruent? Good, equilateral. And one really important thing, equiangular and equilateral go hand in hand. So if all the sides are the same, then it's automatically equiangular. All the angles are also going to be the same. Vice versa. While the angles are the same, that automatically makes it equilateral. All the sides are going to be the same. So if you're stating one of these, you're automatically stating the other as your answer. So these two go hand in hand. If you're writing equilateral, you should automatically write an equiangular and vice versa. Okay? You'll never have an equilateral obtuse triangle. Okay? Those two are always paired up. Okay? What do we call a triangle with no sides? Congruent, Kenzie? Scalene, very good. And what do we call a triangle with two sides? Congruent. Brandon?
I can't read my own title.
No, you're fine.
Yeah, isosceles.
Isosceles, very good. Okay. And again, these green ones on here, based off sides. So we take a look down here. We're going to classify some. We're going to classify it based off its angle and its side. So take a look at that first one. How can we classify it based off its angle? What? That's a right triangle. There's a right angle right there. So that's telling me it's a right triangle. How can we classify this guy based off its sides? Be very careful. Scalene if no sides are the same. This has one tick mark.
Oh, we're not supposed to.
This has one. So what do we call it? Very good. Isosceles. Good. Whenever segments have the same number of tick marks, that means they're the same. So this side and this side are the same. This doesn't have a tick mark, so only two sides are the same. So it's isosceles. What about B? How can we classify that based off its angle? Brandon? Obtuse. Got an obtuse angle right there. And guess what? That makes it an obtuse triangle. What about the sides? Scalene. All three sides are different. This side has one tick mark, this side has two, this side has three. They're all different, which means all the sides are different. What about C? What do we know about all the sides? Are the same, so we classify that as equilateral. What did we say? If it's equilateral, it's also going to be what? Equiangular. So those two go hand in hand. So it's equilateral, which also makes it equiangular. And if it helps, make those little arcs. All four sides are the same, three sides are the same, so all three angles are automatically going to be the same. Okay. What about D? How can we classify that based off all the angles? What do you know about all three of them? What? Carter? They're all acute. Very good. So we would call this an acute triangle. They're all less than 90. Okay? And they're not all the same. You got that one guy that's different. It's not triangular. Okay? What do we notice about the sides? How do we classify this based off the sides? Someone new knows? Actually, I saw it's very good. Two sides are the same, two sides are 4.8, so that would make it isosceles. Very good. Not too bad. Okay. Questions over there? Okay. So we're going to talk about lines involving triangles and the special type of lines that go through triangles. And some of them we talked about the vocab yesterday a little bit. We're just going to see how those segments apply to triangles as well. So one thing we talked about yesterday was a perpendicular bisector. And what two things do we know when we see the word perpendicular bisector? Perfect. It's splitting a side or a line in half, and it's creating right angles. Very good. So that's exactly what happens with a perpendicular bisector of a triangle. Right? It's a line segment array that passes through the midpoint, because it's cutting it in half. So it's passing through the midpoint of a side. Again, the midpoint's the very middle, so it's cutting it in half. And it's perpendicular to that side. What symbol do we use again for perpendicular? Good. Upside down capital T. That means perpendicular. And again, we love using symbols in geometry. We do not like writing out words. You'll see lots and lots of symbols. So we take a look at the diagram here. You have three different lines. We're just going to focus on one. Here's this line. It's passing through the midpoint. I know it's passing through the midpoint because of these tick marks. And then I know it's perpendicular because there's a right angle. So it makes it a perpendicular bisector. So what's going to happen is you're either going to be told in directions that you have a perpendicular bisector. You have to know what you have. Or you're given a picture. And you have to be able to identify the fact that it's a perpendicular bisector. So two things that are really important. I want to make note. Cut a side in half. So you're going to have tick marks. And there's also right angles. And again, I just like to use the angle symbol. That looks like an alligator mouth, rather than writing out the word angle. If you want to write out the word angle, go for it. So when you see the word perpendicular bisector, or you see those things marked on a diagram, okay, you have right angles, and it's cutting the sides in half. An angle bisector we also talked about today. Same thing applies. All it is some kind of ray that's cutting the angles of a triangle in half, creating two congruent angles. Okay. So the symbol for congruent, again, we make the equal sign. What do we draw above the equal sign? Okay. Yeah, little squiggle. Little squiggle means congruent. So that's all that's happening. Here we have a ray coming from this angle. It's bisecting it, just cutting that into two congruent angles. So one big thing to know, whether you're told you have an angle bisector or you're given a picture and you have to decide if you have an angle bisector, one thing to look for is congruent angles. That's what you're looking for. If a triangle has lines going through it and there's congruent angles, then you know that segment's a angle bisector. I think that's the easiest to tell. That's different from all the other ones. Two new vocab words are median and altitude. Okay? A median, what's that sound like? Medium, a little bit. Also kind of sounds like middle, median, middle, medium, middle. Okay? That's how I like to remember a median. It's a segment whose endpoints are a vertex, so one of the corners of your triangle. Look at the diagram. Here's one endpoint. Got the vertex. And then the other endpoint is the midpoint of the opposite side. So it goes down. Here's the midpoint of the opposite side. Here's the median. Okay. So when I like to think of medians, it's cutting the opposite sides in half. Okay? But is it creating right angles? Medians never create right angles. Because if they do, then it makes it a perpendicular bisector. So the only thing you're looking for are tick marks or sides being cut in half. Okay? Sides cut in half. Meaning those tick marks. If they have like congruent pieces, then you know you have a median. No right angles. Absolutely no right angles. You want to make a note? No right. Medians do not have right angles. Because if they do, it makes it a perpendicular bisector. So if you can just remember medians cut sides in half, you're good. It bisects the sides. I like to think of it. Then the last vocab word is altitude. Alright? How I like to think of altitude. It's a segment, starts at one of the vertexes of your triangle, and it literally drops straight down. Straight down. And it's perpendicular to that opposite side. Meaning, what kind of angles does it create? Right angles. Okay? So, altitudes, they're creating right angles. They're perpendicular to the sides. So they're not cutting anything in half. Okay? They're just dropping straight down, creating right angles. That's it. Nothing's being cut in half. So what you're going to look for, or make sure you know, that altitudes create right angles. Okay? There's no bisecting. Nothing's being cut in half. Just a right angle. Big thing for me, just remember medians are cutting the sides in half, altitudes are creating right angles. Okay, those are the big things to remember. Questions over that? Okay. So if we take a look, did everyone get this down? Good. If we take a look here, okay, so determine whether AB is a perpendicular bisector, angle bisector, median, or altitude. I think those notes we talked about and decide. So what do we notice is going on? Here's AB. What do we notice? What kind of angle is it creating? A right angle. So I have a right angle. Then take a look and see. Are these parts congruent? Is it cutting this side in half? Exactly the same. No. So all we have is just right angles. Nothing's being bisected. What would we call this? Altitude. It's just dropping straight down, creating a right angle. Not cutting anything in half. Big thing to remember, when you see the word altitude, think right angles. Okay? What about B? Are there any right angles in B? No, I don't see any right angles. There's no boxes. All I see is that side being cut in half. So what do we call this, Bree?
Angle bisector.
Very careful. This side's being cut in half. But there's no right angles. And there, what do we call this? Median. Remember, medians just cut the sides in half. They're not perpendicular. There's no right angles with medians. It just drops down and cuts that opposite side in half. And I know it's cutting the opposite side in half because these tick marks. If we take a look at C, do we have right angles? No, I don't see any boxes. You can't assume. The box has to be there. Their directions have to tell you. that something's creating a right angle. I don't see any boxes. I don't see any sides being cut in half. But what do we notice at the top? What's happening to angle A? It's getting cut in half because of those arcs, right? So what cuts angles in half? Angle bisector. So I notice up here that angle's being cut in half because of these tick marks that are the same, the arcs. So I'm going to say angle bisector. There's congruent angles. Angles are congruent. I have an angle bisector. Questions over that? No? So now we're going to apply this vocab into solving problems similar to what we did yesterday. Okay? It says, in triangle PRS, PT is an altitude, and PX is a median. So, I like to label. I'm given by vocab words. I like to say, what do I know about those vocab words? Right? It told me that PT is an altitude. I'm going to highlight PT. Right? What do I know about altitudes? What do they make? Right angles. So I know where PT is hitting that side. I know all those angles are right angles. That's what's important to know about that vocab word. Altitudes create right angles. Okay? It told me that PX is a median. There's PX. What do I know about medians? What do they do to the opposite sides? Cuts it in half. So if it cuts it in half, what do I know about SX and RX? They're the same. So I'm going to put tick marks to show that they're the same. This and this are the same. That's what I know. I'm going to mark what I know. It's going to help me set up my problem. Okay? So we take a look at A. It's saying find RS if RX equals x plus 7 and SX equals 3x minus 11. There's a tongue twister. There's like 5 x's in there. Okay? What did we just say about those segments? Because we knew PX was a median. They're what? They're the same. And we talked about this yesterday. What can we do with those segments to set up an equation to help us figure out x's? Equal them to each other. Okay? We just said they're the same because this is a median. Just like we did yesterday. If they're the same, set them equal. And a little helpful hint, if you're dealing with problems like this, and you're given segments, and you're just like, how the heck do I set this problem up to solve? Really, the only thing you can do with segments is set them equal. So if you're given segments and you're stuck, set them equal to each other and solve, more than likely you're right. Okay? This is helpful. If you're stuck on how to set it up the problem. Angles, much different. Angles have a ton of options. Segments, though, really, the only thing we do is set them equal to each other. Okay? Well, we just solve this like a normal equation. I'm going to move the x over. Move the 11 over. Get 18. Divide by 2. I think we're all pretty good at solving equations. And 18 divided by 2 is 9. Are we done with part A? I found x. Am I done? No. What do the directions tell us to find? RS. Okay, so I'm going to go to my diagram. I'm going to highlight RS. Again, what the heck? They didn't give me an equation for RX. We had a problem similar to this yesterday. What can we do to figure out what RX is? RS. What do you think?
Plus what you found at or 9 with the equations.
Yeah, very good. Because it said that SX is 3x minus 11, and it said RX is x plus 7. Well, don't both of those combined make up that whole entire segment? Okay. So we can just take what we got for x and plug it in. Does it matter which one we plug it in for? No. Which one is the easiest one we can plug in for? X plus 7. So we're going to take 9 and plug it into x plus 7. 9 plus 7 is what? 16. So this whole segment right here is 16. But what do we know about this whole segment right here? It's also 16. They're the same. So both of those are 16. What's the distance of that entire line? What is it? 32. Just do 16 plus 16. And that gives you 32. So a helpful hint, when you see the vocab word median, we're setting things equal to each other. Medians are kind of like bisectors. Cutting sides in half, set things equal. If we take a look at B, find RT and measure of angle PTR. If RT equals x minus 6 and the measure of angle PTR equals 5x plus 40. I'm going to ask you this question. Can you set segments and angles equal to each other? No. They're not the same thing. They're totally two different things. You can never set angles and segments equal to each other. So some of you maybe started to do that. You can't. It's illegal. You're not allowed. Okay? So we have to think about what else we know. Well, RT, it's saying it's x minus 6. I'm going to erase some stuff in this diagram so you get a better view of what we're doing. Look back up at my diagram. It said that RT is x minus 6, this little guy right here. Okay. Is there any other segment they gave me in B? We can't use anything in A, they're two different problems. Is there anything in B? Another segment? Anything? No. Okay, so that's not really going to get me anywhere. So I don't have anything to set it equal to. Here, it said that PTR, this angle, right there, is 5x plus 40. I'm going to label it. Well, what else do we know about that angle? Right, very good. So it's 90 degrees. Well, how can we set up an equation to solve? We know that angle's 90 degrees. We also know that it is 5x plus 40. Agree?
5x plus 40 equals.
Good. Yeah, you just take that angle. We know that's a right angle. So you just take the angle and set it equal to 90. Because all right angles are 90 degrees. And then you solve. Okay? Move the 40 over. You get 5x equals 50. Divide by 5. And x ends up equaling what? 10. Again, are we done with this problem? No. What did it want to know? RT, right? Here it said RT was x minus 6. What do you think we can do? Good, plug x in. We got x was 10. Take 10 and plug it in. And 10 minus 6 is what? So RT is equal to 4. Those are tricky ones. A lot of stuff going on. If you're asked these type of questions in the future, it'll be more fun. Okay. All you need to remember is median. Cut sides in half. Set things equal. Altitude creates 90 degrees. Okay. If you remember those things, then we're going to do good. Yeah, sometimes